In the last class, we discussed different properties of thermodynamics properties of bosons, and we also covered the Bose-Einstein condensation conditions, different conditions for Bose-Einstein condensation, and all those things. And in this class, we will be discussing about fermions. These two particles are showing quantum behavior, and the bosons are having integral spin. Fermions are having half integral spin. All these properties we already discussed, and we also discussed all the thermodynamic properties associated with bosons. And in this class we will be discussing about the thermodynamic properties of fermions. And when we consider the thermodynamic properties of fermions, first we consider the thermodynamics of ideal Fermi gas. So where we consider a gas of gas which is made up of particles which are fermions. Okay. So for an ideal Fermi gas, as we know, PV by KT will become ln of zeta. This is ln of zeta. So ln of zeta is equal to sigma E ln of 1 plus z e raised to minus beta E. You can consider it as E or epsilon. If you take capital E as the total energy, okay, and then you have to take this as epsilon. Okay. So in I will be talking about this term. I will be expressing it as E, but it is epsilon. Okay. So so this is total energy. Okay, this will be equal to summation of for all the energy state. For example, E1 is having n1 number of particles, E2 is having n2 number of particles. Sorry, epsilon 2 as second energy level is having n2 number of particles, and so on. So if you take all this summation of all these terms, then you will be getting the total energy. So E1 is the energy of the first energy level, average energy of the first energy level, and that is having n1 number of particles, and similarly for the next term. So if you take the summation of all these terms, then you will be getting total energy E. So you can consider this as epsilon. Okay. So this total number of particles will be equal to sigma epsilon. This is occupation number, average value of that occupation number, and then this is equal to sigma epsilon 1 by z raised to minus 1 e raised to minus beta epsilon plus 1. These equations we already discussed many times. And the fermions, for the case of fermions, unlike bosons, we do not have any restriction on this z value. Z is not restricted to 1. We took this z value, maximum value of this as 1 in the case of boson, but that is not here. So this z value is not restricted to 1. It can vary from 0 to infinity. Okay. Similarly, large number of particles in a state is not allowed, because we are considering fermions which obeys Pauli exclusion principle. Okay, so we cannot have large number of particles in the same state. That also we have to consider when we treat the fermions. Okay, and if you consider a large volume, which means the energy level separation is small, and we can replace this summation with these summations can be replaced with integration. Okay, this summation can be replaced with integration along with the term GED. So that is this summation can be replaced with integral, or you can say it is G epsilon d epsilon. Okay, so and that you substitute, and the value of that G is substituted here, This substitution we already discussed many times in the previous classes, so I'm not going to do that. So PV by KT will become 2 pi V by h cube 2m raised to 3 by 2 integral 0 to infinity e raised to 1 by 2 ln of 1 plus z e raised to minus beta epsilon d epsilon. Okay, so we have to include these epsilon terms inside this integration, and all other terms are constant that taken out. So we have this GE you can get from here, GED, so D is here. So all the remaining terms are G or G epsilon, okay, except this ln of 1 plus D minus beta epsilon. So that is already here, as you can see here. Okay, so that is the term PV by KT. And if you do the integration by parts, then you can write PV by KT equal to 2 pi V by h cube 2m raised to 3 by 2. And if you do this part integration of this part, then you can write this as first term, then ln of 1 plus z e raised to minus beta e. If you integrate this one, that will become e raised to 3 by 2 by 3 by 2, and that has to be given the limit 0 to infinity. Okay, so when you give this limit and the second term, okay, we have to discuss second term also. So minus integral of 0 to infinity, integral from 0 to infinity, derivative of that first term, that is ln of 1 plus z e raised to minus beta epsilon. So if you take the derivative of that, then that will be 1 by 1 plus z e raised to minus beta epsilon into z e raised to minus beta epsilon into minus beta. Okay, and then we have the integral of second term. So integral of e raised to 1 by 2. So that is e raised to 3 by 2 by 3 by 2 d epsilon. So if you apply this limit 0 and infinity on this term, first term, then that will become 0, because when you apply this first, for example, infinity in this term, then e raised to minus infinity will come, and that will become 0. So only log 1 will be there, that is 0. So that will make this term 0. And if you substitute this 0 for epsilon, then this term directly is going to become 0. So that both terms will become 0. That will make the entire first term will be 0 after applying these limits. Then only the second term remains. So this negative and this negative inside this along with this beta, that will give this term positive. This term will become positive, so that we will get PV by KT as 2 pi V by h cube 2 pi V by h cube 2m raised to 3 by 2 2 by 3 beta integral 0 to infinity epsilon raised to 3 by 2 z raised to minus 1 e raised to beta epsilon plus 1 d or d epsilon. Now put beta epsilon equal to x, then dx will become beta into d or de equal to dx by beta. Epsilon raised to 3 by 2 will be equal to x raised to 3 by 2 by beta raised to 3 by 2. Okay, then PV by KT is equal to 4 pi V by 3h cube. Substitute this value in here in this integration part. So 2 pi V by h cube, all these terms are constant, and this epsilon raised to 3 by 2 will become x raised to 3 by 2 by beta raised to 3 by 2. That beta raised to 3 by 2 I'm taking outside, and then integrate 0 to infinity x raised to 3 by 2 by z raised to minus 1 e raised to x plus 1 dx. Okay, and okay, this we will be having one beta here, but that beta will be cancelled with this beta, and this is the final expression. And now p by kt, if you take p by kt, then that is nothing but this v get cancelled, and then p by kt will become 4 by 3 root pi. I'm just multiplying 1 root pi here. 1 root pi I'm multiplying here. For example, if I multiply here 1 root pi, and here I am also multiplying 1 root pi, so that will not change this expression. So this root pi and this pi, that will become pi raised to 3 by 2, then that I can take inside this 2m term. So we have 4 by 3 root pi, then inside this we are having 2 pi, and this beta is nothing but 1 by kt. I can take it along with this numerator. So 2 pi mkt will come here, whole raised to 3 by 2 by h cube. Okay, this h cube. So that will be okay, that is multiplied with 0 to infinity, this integration x raised to 3 by 2 by z raised to minus 1 e raised to x plus 1 dx. Now what is this term? This is nothing but 1 by lambda cube. This is 1 by lambda cube. Lambda is h by root 2 pi m kt. So this is 1 by lambda cube that I have given here, 1 by lambda cube into 4 by 3 root pi integral 0 to infinity x raised to 3 by 2 z raised to minus 1 e raised to x plus 1 dx. Okay. Now we can write this f nu of z. Let us define this Fermi Dirac function. So that is f nu of z. Similar function we derived for bosons also. So this is Fermi Dirac function. There we are having Bose-Einstein function. This is Fermi Dirac function f nu of z, that is equal to 1 by gamma of nu, f nu, capital F nu of z, and that is equal to 1 by gamma of nu integral 0 to infinity x raised to nu minus 1 by z raised to minus 1 e raised to x plus 1 dx. And this can be simplified as f nu of z, that is equal to z minus z square by 2 raised to nu plus z cube by 3 raised to nu minus etc. So this also can be represented as a series similar to that we have done for the bosons. So p by kt will become p by kt. So the last term in that expression for p by kt can be replaced with this equation. Okay, because we are having integral of 0 to infinity, this term in that last expression. So that can be replaced. So p by kt will become 4 by 3 root pi 1 by lambda cube, then gamma of 5 by 2 and f of or f5 by 2 of z. Okay, f5 by 2 of z. So that is actually coming from here. So if you are having this term, this integral, then you can take this gamma along with this term. So it will become f nu of z into gamma of z equal to integral 0 to infinity x raised to nu minus 1 by z raised to minus 1 e raised to x plus 1 dx. So we have this kind of term in our expression for p by kt. So that can be replaced with gamma of nu into f nu of z. So that what we have done here. So that is nothing but in our case it is this is x raised to 3 by 2. So nu must be 5 by 2 because here it is nu minus 1, and in our expression for p by kt we are having x raised to 3 by 2. So obviously this nu must be 5 by 2. So we will be having gamma 5 by 2 and f5 by 2 of z. But gamma 5 by 2 we know gamma 5 by 2 is 3 by 2 times gamma of 3 by 2, and that is 3 by 2 into 1 by 2 times gamma of 1 by 2, and gamma of 1 by 2 is root pi. So this will become 3 by 4 root pi. Gamma of 5 by 2 will become 3 by 4 root pi. Substitute that, then we will be getting P by KT equal to 1 by lambda cube F phi by 2 of Z. F phi by 2 of Z. And all other terms will be cancelled out because this is 3 by 4 root pi, this is 4 by 3. In the denominator we have root pi, so that terms will be getting cancelled. So only this term will be remaining. So for bosons we are having this expression P by K, sorry, for fermions we are having this expression P by KT is equal to 1 by lambda cube F 5 by 2 of Z. Okay. Now if you consider the weight factor arising from the internal structure of fermions, okay, internal structure of the particles, so that is G, weight factor is nothing but G. So if you include that also in this expression, then P by KT will become G by lambda cube F of F 5 by 2 of Z. Okay, where G is the weight factor that is coming from the internal structure of the particle. And similarly, if you consider this expression, second expression for the total number of particles, okay, so in if you consider that expression, then n can be written as 0 to infinity 2 pi v by h cube 2m raised to 3 by 2. That summation also we are replacing with integration with the term g epsilon d epsilon or GED. So 0 to infinity 2 pi v by h cube 2m raised to 3 by 2 epsilon raised to 1 by 2 by z raised to minus 1 e raised to beta epsilon plus 1 d epsilon. So this is the expression for total number of particles or fermions, and put beta e is equal to x here. The same procedure we are repeating for doing that integration. So beta epsilon equal to x, d epsilon will become dx by beta. This expression we already discussed. So epsilon raised to 1 by 2 will become x raised to 1 by 2 by beta raised to 1 by 2. So substituting that in this expression, then we will be getting n equal to 2 pi v by h cube 2m kt by kt raised to 3 by 2 integral 0 to infinity x raised to 1 by 2 z raised to minus 1 e raised to x plus 1 dx. Okay, just you substitute that, then you can easily obtain this e raised to epsilon raised to 1 by 2 will be replaced with x raised to 1 by 2 by beta raised to 1 by 2. So that beta raised to 1 by 2 I'm taking outside, okay, with this from this term. And also we are having a term d epsilon here. D epsilon is dx by beta, that beta also coming to picture, and that term, so all over that beta and root beta, that will become beta raised to 3 by 2, and beta is 1 by kt, that I have taken along with this term. So all those steps are taken care of, then we will be getting the final expression for n is like this. And n by v will become, you just take this v into the side, then you will get n by v is equal to 2 by root pi. That is the same procedure that we did in the previous case. Just multiply here a root pi and divide a root pi. So we can have by root pi. So we can have root pi into pi. This pi will here it will become pi raised to 3 by 2, that you can take inside of this bracket. Okay, then that will become 2 pi kt 2 pi m kt raised to 3 by 2 by h cube, that is nothing but 1 by lambda cube. And then we are having this integration term. This integration can be replaced with gamma of 3 by 2 into f 3 by 2 of z. And the new value in this, if you compare the Fermi Dirac equation, you can see here Fermi Dirac equation here, so that this Fermi Dirac equation or function, Fermi Dirac function. So if you compare this with the integration term in that expression, then we can see nu will be 3 by 2. So just write that, then we can replace that integration with the gamma of 3 by 2 into f 3 by 2 of z. Then gamma of 3 by 2 is nothing but 1 by 2 into gamma of 1 by 2, that is 1 by 2 root pi. So substituting that and cancelling that 2 by root pi and root pi by 2. Okay, then we will get 1 by lambda cube f3 by 2 of z. So n by v, that is the number density, total number of particle divided by total volume, then that will be 1 by lambda cube f3 by 2 of z. And if you include weight factor here, also weight factor is nothing but g, then that will become n by v equal to g by lambda cube f3 by 2 of z. And from here, if you calculate the internal energy U equal to minus dou by dou beta of ln zeta, and U will become kt square. If you replace this beta with 1 by kt and replace dou by dou beta with dou by dou t, then we can write it as U equal to kt square dou by dou t of ln zeta. Okay. If you replace dou by dou beta with dou by dou t, that is nothing but dou by dou beta can be replaced with this kt square, this is minus kt square dou by dou t. Okay, so you replace that term, then you will get kt square dou by dou t of ln zeta, which is equal to kt square dou by dou t of pv by kt. Okay, and because ln zeta we already discussed, this ln zeta is nothing but pv by kt, and then we have this is equal to kt square times v, we can take outside, into dou by dou t of p by kt. So because we are having this expression, that's why we are keeping it inside, and we know what is p by kt. So just substitute that here, then if you take the derivative with respect to t, then we will get the energy U. Okay, that's what we have to do now. So now if you take dou by dou t of that entire term, then we can write it as U equal to kt square v, U equal to kt square v times dou by dou t g by lambda cube f5 by 2 of z. Okay, so that is U, and if you take the derivative of this term with respect to t, then this f5 by 2 of z you can take outside, and g also, that is a constant, then only this lambda is dependent on t. So 1 by this will become 1 by lambda cube, so dou by dou t of 1 by lambda cube. So if you take this derivative, then u will become 3 by 2 ktb g by lambda cube f5 by 2 of z, f5 by 2 of z. So that is the expression for the energy U, and then this is U equal to 3 by 2 PV, U equal to 3 by 2 PV, and then P will become 2 by 3 U by V. P will become 2 by 3 U by V. This you can simply perform, because you just have to substitute this lambda as h by in lambda, not 1 by lambda. Lambda is h by 2 pi m kt raised to 1 by 2, or root 2 pi m kt. So just take the derivative of this t raised to 1 by 2. Okay, and then that will become t raised to, if you take that into the numerator, then it is t raised to minus 1 by 2, then that will become minus 1 by 2 times t raised to minus 3 by 2, minus 1 by 2 minus 1, that is minus 3 by 2, and one of that minus 3 by 2, that is nothing but t raised to 1 by 2 into t. That t raised to 1 by 2 will again come with this bracket term. Then that will make this lambda cube term again, and one t remains, one more t will be there. Okay, that will be cancelling one of this t square in this t square, and all other terms are there. Okay, so that we'll get this expression. Okay, so okay, this is actually this is lambda cube, so this will become h cube by this raised to 3 by 2. So that how this 3 by 2 is coming, so 3 by 2 will come here, and then all other terms are there, then only this t will cancel with the extra t which is coming with the t raised to 3 by 2. So this is actually that will become, if you take the derivative, then first you have to consider t raised to minus 3 by 2 in the numerator, then that minus 3 by 2 will come here. Okay, after derivation, then this is minus 3 by 2 minus 1, so that it will become minus 5 by 2, and from that you can take 1 3 by 2, so t raised to 3 by 2 into t. Okay, so that this t by 3, t raised to 3 by 2 again will go inside this lambda cube, and then one t remaining, that will be cancelling this t, one t here. Okay, so all the remaining terms are there, so that is what we have to do here. Okay, then after that we know what is this term p, or you know what is p by kt, you know what is p by kt, you just use that equation, and that is this term g by lambda cube, this term g by lambda cube f5 by 2 of z, that is g by, that is nothing but b by kt. So if you substitute that, then this kt and kt will get cancelled, then only this p remains. So this is nothing but pv, sorry, p by kt, this is p by kt. So if you substitute that, then you will get u equal to 3 by 2 pv, or p equal to 2 by 3 u by v. What is u by v? U by v is the energy density. So 2 by 3 times energy density. Pressure is equal to 2 by 3 times energy density. So for fermions, okay. And specific heat capacity, how we can calculate specific heat capacity? That is nothing but dou u by dou t at constant n and v, constant volume and number of particles. So specific heat capacity Cv equal to dou u by dou t at constant n and v. So this is the expression for the energy, that is 3 by 2 ktv g by lambda cube f5 by 2 of z. And we also know n by v. N by v, we know that g by lambda cube f3 by 2 of z. Okay. Now what we need? Dou u by dou t. For specific heat, we need dou u by dou t. But before that, we have to express this u in terms of this f3 by 2 of z, and we can write it as 3 by 2 ktn. Because this is n by v is equal to g by lambda cube f of 3 by 2 of z. Then you can write this lambda cube. You can write this lambda cube equal to v by n times g f3 by 2 of z. So that you substitute in this lambda cube, then we can write it as u equal to 3 by 2 kt. This v and this v will get cancelled. Okay, when you take 1 by lambda cube, it will become inverse of that, so that this will be v and this v and get cancelled, then ktn f5 by 2 of z by f3 by 2 of z. Now cv by nk, if you take cv by nk, that is 1 by nk times 3 by 2 nk dou by dou t of t into f5 by 2 of z by f3 by 2 of z. What is this? This is this expression. Okay, we have to take the the derivative of this equation with respect to t. That what we are doing here. Okay, and we have one additional term nk here. Okay, that is multiplied here 1 by nk times, and this is equal to 3 by 2. This nk and this two will get cancelled, and then this becomes 3 by 2 dou by dou t of t into f5 by 2 by f3 by 2. This is f5 by 2 of z and f3 by 2 of z. Okay, so cv by nk equal to 3 by 2 times f5 by 2 by f3 by 2 plus, because when you take this differentiation with respect to t, then you have to take these two terms. You have to consider these two terms. Then dou by dou t of this t will become 1, and the remaining term is 5 by 2 by f3 by 2. We are doing the uh, multiplication rule here. Okay, so this f5 by 2 by f3 by 2 plus t into, then we have the second term, so t into dou by dou z of f5 by 2 by f3 by 2 into dou z by dou t at constant volume. So this dou by dou t can be replaced with dou by dou z into dou z by dou t, and then we have cv by nk equal to 3 by 2 into 3 by 2 into f5 by 2 by f3 by 2 plus 3 by 2 1 by f3 by 2 of z dou by dou z of f5 by 2 of z into dou z by dou t. Okay, then plus, so we have to uh, do this differentiation dou by dou z of this entire term, so that will become first term will become like this is corresponding to this term, and the second one is for this entire term. So this is 3 by 2 1 by f3 by 2 of z in the numerator into dou by dou z of f5 by 2 of z dou z of dou z by dou t plus 3 by 2 t 3 by 2 t times this multiplied with minus f 5 by 2 of z by f3 by 2 of z square dou by dou z f of 3 by 2 of z dou z by dou t. But we know n by v equal to g by lambda cube f3 by 2 of z. So this is this you have to, from this we can take what is f3 by 2. f3 by 2 of z is n lambda cube by g, or we can write n by g. Lambda is nothing but h by root 2 pi m kt. So you substitute that here, then we will get this expression. Okay, and from that we can write dou by dou t of f3 by 2 of z. This we already did it for the case of bosons also, same procedure. So then dou by dou z, or sorry, dou by dou t of f3 by 2 of z, that will be equal to, you just take derivative of this term with respect to t, then we will be getting an extra minus 3 by 2 t raised to minus 5 by 2 term, and from this t raised to minus 5 by 2, one of that t raised to minus 3 by 2 will be joining with this term 2 pi m k, so that we will get that lambda cube again. So this will become minus 3 by 2t f3 by 2 of z, f3 by 2 of z. And if you further take dou by dou z of f of 3 by 2 f3 by 2 of z, then that is dou by dou z of this series z minus z square by 2 raised to 3 by 2 plus z cube by 3 raised to 3 by 2 minus etc. So if you take the derivative, then this term will become 1, this term will become z, so that this will become 1 minus z by 2 raised to 3 by 2. Okay, and then okay, this is I think this is 1 by 2, right? This is 1 by 2, not 3 by 2. This has to be 1 by 2 because we'll be having 2 times here 2z, so that 2 and 1 2 from the denominator will get cancelled. Then we have here z cube, so if you take derivative 3z square will come, so here we'll be having 3 and here we are having 2, so this 3 and this will get cancelled, so this will become 3 raised to 1 by 2, not 3 by 2, this is 3 raised to 1 by 2, and so on. Okay, so then if you multiply an additional z with this term, okay, z into dou by dou z of f3 by 2 of z, then that will become this term is multiplied with z, so first term will become z, second term will become z square by 2 raised to 1 by 2. Okay, this is 1 by 2, not 3 by 2, and then z cube by 3 raised to 1 by 2. Okay, and so on. So that can be written as f1 by 2 of z, f1 by 2 of z. So now we know what is z dou by dou z of dou by dou z f3 by 2 of z. Okay, so we have to use these expressions in the above equation. So in general we can write z dou by dou z f nu of z equal to f nu minus 1 of z. Okay, so what we have derived is z dou by dou z of uh, f3 by 2 of z, this is equal to f1 by 2 of z, that what we have done here. But in general we can say if you are having a value of nu, f nu of z, then if you take the derivative of that with respect to z and multiply z with that term, then you will be getting f nu minus 1 of z. Okay, so by using this you can calculate any value. You can convert any value into this z into dou by dou z of f nu of z. So for example, z dou by dou z of f5 by 2 of z will become f3 by 2 of z. Now cv by nk will become 3 by 2 f5 by 2 by f3 by 2 plus 3 by 2 t f3 by 2 by z. All these terms are dependent on z, f5 by 2 of z, f3 by 2 of z. Then 3 by 2 t f3 by 2 of z by z into 1 by f3 by 2 of z into dou z by dou t plus 3 by 2 t minus 1 by f3 by 2 square f5 by 2 into f1 by 2 by z dou z by dou t. All these terms are, you can just substitute this z dou z dou by dou z of f nu of z. Instead of that, you can substitute the corresponding values, then you will get this expression. So cv by nk will be again you can reduce it as 3 by 2 f5 by 2 of z by f3 by 2 of z plus then this term remains 3 by 2 t. Okay, yes, so this is minus 3 by 2 t for this second term you consider, and all other terms are there. This is f3 by 2 here. Okay, and I think this is 1 by f, and this term this is z, right? So this is 3 by 2 t, then we have minus 3 by 2 t f3 by 2 by f1 by 2. This you can get from this 1 by z dou z by dou t. What is that? 1 by z, I think okay, so 1 by z, I had to write it here, 1 by z dou z by dou t, this is equal to 1 by z dou z by dou t, that is equal to minus 3 by 2t, minus 3 by 2t and f3 by 2 of z by f1 by 2 of z, f1 by 2 of z. Okay, how it is coming? If you go to the previous equation, and if you take the this expression, for example, dou by dou t of f3 by 2 of z, here we are having dou by z into dou by dou z of f3 by 2 of z. If you divide these two, then we will get 1 by z dou z by dou t. Okay, these two will get cancelled, f3 by 2, f3 by 2 will get cancelled. So 1 by z dou z by dou t will come. Okay, that is equal to, if you take the derivative of this side also, then we have here minus 3 by 2t f3 by 2 of z, we are having f1 by 2 of z. So that's how we'll get 1 by z dou t, sorry, dou z by dou t is equal to minus 3 by 2t times f3 by 2 of z by f1 by 2 of z. So that we have to substitute here. So this expression also you have to consider, and that you substitute in this equation, then that term will be coming like this: minus 3 by 2t f3 by 2 by f1 by 2. This 2 will get cancelled, and the remaining term will be replaced with this expression. Similarly, for the next term, minus 3 by 2, this negative sign will come here. So minus 3 by 2 t f5 by 2 by f3 by 2. This again we'll be having the term here minus 3 by 2t f3 by 2 by f1 by 2. Okay, actually we'll be having f3 by 2 here also, but that will be cancelled. So this is f5 by 2 by f3 by 2. Okay, then this f1 by 2 is there, and all other terms are there. So this is dou z, this is 1 by z, again we'll be having 1 by z dou z by dou t here. So you just substitute for that f3 by 2 by f1 by 2, minus 3 by 2t f3 by 2 f by f1 by 2. Okay, then from that, this expression, if you cancel the terms, and finally we get 15 by 4. So 15 by, how it is coming, 15 by 4. So first you have to multiply this term. So this is 3 into 3 9, minus 9 by 4 will come here, minus 9 by 4, this t and this t will get cancelled. So minus 9 by 4 f3 by 2 by f1 by 2, that is the second term. Then here we are having minus 3 by 2 and 1 t here, so this 2 will get cancelled. So this is minus, this is also minus, so this is plus 9 by 4 f5 by 2 here. So this is, this 3 by 2 and this 3 by 2 will get cancelled. So f5 by 2 by f1 by 2. Sorry, this is f3 by 2. So one more f3 by 2 will be here. So one f3 by 2 remains. So this 2 will get cancelled, f1 by 2, f1 by 2, and this is, I think this will be having square, right? So one of that will be cancelled, so that we will get minus 9 by 4, sorry, plus 9 by 4 fy by 2 by f3 by 2. So 9 by 4 plus 3 by 2 will come here. These two terms are same. So then we'll have 9 by 4 plus 3 by 2. That is nothing but how much it is, 9 by 4 plus 3 by 2, right? Or any other terms are there? This is f5 by 2, 9 by 4, 9 by 4, same 9 by 4, this is 3 by 2, yes. So if you take this, then this is 18 plus 12, so this is 30 by 8, right? 30 by 8, that is 15 by 4. So 15 by 4 times f5 by 2 by f3 by 2 minus 9 by 4 f3 by 2 by f1 by 2. Now from this Cv by Nk, we know what is Cv now. Cv is Nk times this term, and now Helmholtz energy is A equal to mu n minus Pv. So A equal to mu n minus Pv. If you substitute the values, then we will get A equal to Nkt ln z minus Nkt Fi by 2 by F3 by 2. Okay. Then if you consider the entropy, consider entropy. So this is entropy is U minus A by T. U minus A by T. So this is coming from this expression. Okay, so this is, we are having PV here. We know what is P by KT. We also know what is this NKT. Sorry, for expression for N, this is, if you consider this term, NV. Okay, so N by V equal to G by lambda cube F3 by 2. So we have already considered that here. So if you consider V, instead of V, if you substitute this entire term, or you can directly take, I think we already have mm, I think we already did that expression here somewhere. N for N, I think somewhere we already performed this expression. So for f5 by 2 by f3 by 2, okay, so that will be coming f5 by 2 by f3 by 2. You just check that. I think this is here, u, for u it is here, and n by v we are having this expression g by lambda cube f3 by 2, okay, f3 by 2 of z. So from that we actually have to get PV. So for PV we can substitute this term nkt f3 by 2, sorry, f5 by 2 by f3 by 2, or which is, you can take it like that is PV equal to this term, so that is PV by KT, PV by KT, this is equal to PV by KT is equal to n times f5 by 2 by f3 by 2, or you can take okay, you can take it like P by KT, that we know the expression, divided by P by KT divided by N by V. Okay, you just take this, N by V we are having here, and then P by KT also we have expression for P by KT. So if substitute that values, then we will be getting this expression for PV. Then that will give you the Helmholtz equation, Helmholtz sphere energy. Then S equal to U minus A by T, that is entropy. Entropy is the internal energy U minus A by T. So from that you just substitute for U, that we already did, calculated what is U, and then you substitute for A, that is here, and divided by T. So that we will get entropy is equal to Nk 5 by 2 F5 by 2 by F3 by 2 minus ln of Z. So this is the entropy of the Fermi gas, ideal Fermi gas.